Hello friends, this is last part of CPET 2021 Mathematics question answer video. In this video, I explain complete solution and detailed explanation. The previous part are in iTab. Now let us start. Now come to question number 51. Here the question asks about if G is a group, then for all A, B belongs to G, which of the following statement is true? And here we have A, B, this belongs to the set G. And we know that for a group G, the product AB inverse, this is equal to always B inverse and A inverse. So here option B is correct one. Now come to another question, that is question number 52. Here, if H1 and H2 are two subgroups of G, then which of the following is a subgroup of G? Here we know that H1 is subgroup of G and H2 is subgroup of G, and we know that H1 intersection H2, this is a subgroup of G, but H1 union H2, this may not be a subgroup. So here this one is the correct answer. So option A is correct one. Now come to another question. Here the order of convergence of Newton-Raphson method is how much? We know that the order of convergence of Newton-Raphson method is 2. So here option B is correct one. Clear? Now come to question number 54. Here given f of x is equal to, this one is 1 by x, and we have to find what is the divided difference f of, this one is x0 comma x1 comma x2, this is equal to how much? We know that the formula, that is the value of this is, this one is f of, this one is x1 comma this one is x2 minus f of, this one is x0 minus x0, this one is x1, this quantity, whole divided by, this one is x2 minus, this one is x2 minus, this one is x0. Clear? Now we have to evaluate this quantity. So this gives, this one is f of x2 minus f of x1 divided by, this one is x2 minus, this one is x1, this quantity minus, similarly this can be written as f of, this one is x1 minus, this one is f of x0 whole divided by, this one is x1 minus x0, this whole quantity, this divided by, this one is x2 minus, this one is x0. Now we have f of x is equal to 1 by x. So 1 by x, so in the place of x we have to write x2. So f of x2 is 1 by x2. So rewriting this, we get, this one is 1 by, this one is x2 minus 1 by, this one is x1, this divided by, this one is x2 minus x1, this quantity minus 1 by x1 minus 1 by x0 whole divided by, this one is x1 minus this quantity x0, and this whole quantity, this divided by x2 minus this one is x0. Clear? So this can be rewritten as 1 by, this one is x2 minus x0, this whole quantity, into, here this one is x1 minus this one is x2 divided by, this one is x1 x2 whole divided by, this one is x2 minus x1, this quantity minus, this one is x0 minus x1 divided by x1 into x0 this quantity divided by this one is x1 minus this one is x0. Clear? Now this one is 1 by this one is x2 minus this one is x0, and this bracket here observe that this quantity x1 minus x2, this one is x2 minus x1. So on cancelling, this one is minus 1 divided by this one is x1 into x2, this quantity minus this one is minus 1 divided by similarly x0 minus x1, this one is x1 minus x2. So by cancelling this and this, we get this one is minus 1 by this one is x1, this one is x2, sorry x0. Clear? And on solving this, we get 1 by this one is x2 minus x0 into this one is x1 x2, x1 x0. So LCM is here, LCM is x1 x2 and this x0 and x1 x2. So in this case minus of x0, and this minus minus this one is plus, and x1 x0 in this place this one is x2. So this one is x2 minus x0, x2 minus x0. This quantity and this quantity cancel out, and the final answer is 1 by this one is x0, x1 and x2. So 1 by x0, x1, x2. So option A is correct one. Here option A is correct one. Clear? This is the formula to evaluate this quantity, and the final answer is option A. Now come to another question. The question 55. Here given that f of 0 is equal to 1. Here f of 0 is equal to 1, and this one is f of 1 is equal to 3, and f of 3 is equal to this one is 55. Then the quadratic Lagrange polynomial is how much? So so by putting the direct formula of Lagrange polynomial, it is easier to check these points in this polynomial. So first of all, f of 0 is equal to 1. So in place of x is equal to 0, we get the y value as 1. So putting the value of x is equal to 0 in option A, we get here in place of x is equal to 0, we get this one is minus 1, because here observe that this one is 8 into 0 minus 6 into 0 minus 1. So here the result is minus 1. So this one is f of 0 is equal to 1. So option A is wrong one. Similarly, option C also wrong one, because here minus 1 is present. So our option, either option B is correct or option D is correct. Now check option B. So here 8x square minus this one is 6x plus 1. So in place of x is equal to 0, we get this one is 8 into 0 minus 6 into 0 plus 1. This gives 1. So f of 0 is equal to 1. This one is true. Now we have to put f of 1 is equal to 3 and check whether f of 1 gives 3 or not. So in place of x is equal to 1, we get this one is 8 into 1 minus 6 into 1 plus 1. This gives 8, and this one is 8 plus 1, this one is 9 minus 6, this gives 3. So f of 1 is equal to 3. And in option D, here observe that D is 8x square plus this one is 6x plus 1. So this one is 8 into 1 plus 6 into 1 plus 1. This one is 8 plus 1 plus 6. This one is 8 plus 1 9, 9 plus 6, this one is 15. So here f of 1 is equal to 3. This one is f of 1, this not is equal to 3. So option D is wrong one. So option B is correct one. So here option B is correct one. Here option B is correct one. Clear? Now come to question 56. Here we have to find what is the Newton-Raphson scheme for finding the smallest positive root of the equation fx is equal to x cube minus 5x plus 1 equal to 0. And we know that the Newton-Raphson formula, that is Newton-Raphson formula, this is equal to, this one is x k plus 1, this is equal to, this one is xk minus, here is the f of xk divided by f dash of xk. And in this case we have given as f of x is equal to, this one is x cube minus 5x plus 1, this is equal to 0, or this quantity. So from this we can get f of xk, this is equal to, this one is xk cube minus 5xk plus 1, and we have to find what is the value of f dash of xk. So f dash of xk, this gives, this one is 3xk whole square minus 5. Now putting these values in equation this, one, let this be the star. So we have, this one is xk plus 1 is equal to, this one is xk minus f of xk. So what is the value of f of xk? This one is xk cube minus 5xk plus 1 whole divided by this quantity f dash of xk. So this one is 3xk square minus 5. Now on solving this we get the LCM is, this one is 3xk square minus 5, and on multiplying xk into this gives, this one is 3xk cube minus 5xk, this one is minus xk cube, and minus minus, this one is plus 5xk minus 1. So these 5xk and 5xk cancel out, and from this we get, this one is 2xk cube minus 1 divided by, this one is 3xk square minus 5. So from option xk plus 1 is equal to 2xk cube minus 1 by 3xk square minus 5. So option A is correct one. Clear? Now come to another question, that is question number 57. Here observe that we have to solve the linear programming problem, and the problem is maximize z is equal to x1 plus x2 and subject to the constant, this one is x1 minus 2x2 less than is equal to 10, x2 minus 2x1 less than is equal to 10, and x1 and x2 greater than is equal to 0. Here observe that the feasible region is this region. Here is these are the feasible region. Clear? So and this pink region is the feasible region, because here x minus 2y less than is equal to 10, this equation, and minus 2x minus y less than is equal to 10, this one is this equation. So here the options are, the LPP admit an optimal solution. Here observe that there is no optimal solution here, and the LPP is unbounded. Obviously the LPP is unbounded because in the feasible region it never meets any point. So this one is the unbounded problem. And third one, the LPP admit no feasible solution. This is the wrong one. Then the LPP admit unique feasible solution. This one is also a wrong one. So option B is correct one. Here option B is correct one because the LPP is unbounded. Clear? Now come to another question. Here we have to solve the LPP, and given as minimize z is equal to x1 plus x2 subject to the constant 2x1 plus x2 greater than or equal to 4, and x1 plus 7x2 greater than or equal to 7 and x1 x2 greater than or equal to 0. So here the feasible region is this region. On plotting this region gives look like this type of. So this brownish color region is the feasible region. So here observe that this one is the minimum point, and this minimum point is the intersection of two equations. And the intersection equation, the two equations are, this one is 2x1 plus this one is x2 is equal to 4, and another equation is x1 plus this one is 7x2 is equal to 7. And observe that we have to find the minimum quantity. What is the minimum value of z? So from the feasible region, we can conclude that this point gives the minimum value, and this point is the intersection point of these two equations. So on solving these two equations, we get the value. So put it as the equation 1 and put it as equation 2, and on solving this, we get, on multiplying this whole equation with 2, we get and taking minus, this one is minus and minus, this cancel out. So minus 7x2 and plus x2, this gives minus 7 into 2, that means this one is minus 14, this one is minus 13 x2 is equal to 14, this one is minus 10. So this gives x2 is equal to 10 divided by 13. So x2 is 10 by 13. Now come to x1. So this x1 is equal to 7 minus this one is 7x2. So this one is 7 minus 7 into this one is 10 by 13. So this one is 91 minus 70 divided by 13. This is equal to 21 divided by 13. So x1 is equal to 21 by 13 and x2 is equal to 10 by 13. So here option A is correct one. At the point x1 is equal to 21 by 13 and x2 is equal to 10 by 13, we get the minimum value, because on plotting this feasible region, we get the solution, because this point gives the minimum value. Now come to another question. So which of the following is true? Here option A says that if primal has a feasible solution, then its dual will also have a feasible solution. No. If primal has no feasible solution, then its dual will have no feasible solution. This one is wrong. If both primal and dual have feasible solution, then both will have bounded optimal solution. No. Last one. If primal has no feasible solution, then its dual will have an unbounded solution. This one is the correct answer. So here option D is correct one. Now come to another question. So here in linear programming problem, here option A is says that objective function, constant and variable are linear. Obviously, because this one is the linear programming problem. So option A is correct one. Now come to option B. Only objective function to be linear. No, this one is not. Only constant to be linear. No, this one is also wrong. And only variables to be linear. No, this one is also wrong. So here option A is correct one, because in a linear programming problem, objective function, constant and variable are all linear in nature. So the question 61. Here if A and B are independent event, then probability of A given B is how much? So probability of A given B, this can be written as probability of A intersection B divided by this one is probability of B. And we know that if A and B are independent event, then this probability of A intersection B can be written as probability of A into this one is probability of B divided by this one is probability of B. So this probability of B and probability of B cancel out, and this gives probability of A. So probability of A given B, this is equal to probability of A. So here option C is correct one. Here option C is correct one. Now come to another question, that is question number 62. Here, if A and B are mutually exclusive event, then what is the value of probability of A intersection B? So mutually exclusive event. That means one event is happen and another has no. Like an example, one coin is tossed, then either head is out. The outcome is either head or tail. Simultaneously, head or tail cannot be found. So this type of things are known as mutually exclusive event. So here probability of A intersection B, this quantity always be 0. So here option B is correct one. As if we toss a coin, then either we get head or tail. So simultaneously we cannot find head or tail. If the event A is as the outcome head is occur and event B is outcome tail is occur, then A intersection B always this gives the 0 and probability is 0. So here option B is correct one. Now come to question number 63. Here let x be a continuous random variable and f be a probability density function of x. Then which of the following is true? Here first option says that f of x is less than 0, less than is equal to 0, and x lies between minus infinity to infinity. No, this one is wrong. And second bit, this gives integration over minus infinity to infinity, and this one is f of x dx, this is equal to 1. This one is the correct. This one is correct formula. This one is the direct formula of probability density function of x. So here option B is correct one. Now come to T4. Here the simultaneous limit xy tends to 0 comma 0 and xy cube by x square plus y to the power 6 is equal to how much? So we have to evaluate this. So this gives, the question is, this one is limit x comma y, this goes to 0 comma 0, and the function is x y cube divided by, this one is x square plus y to the power 6. Here we have to substitute something. Let us substitute, this one is y cube is equal to mx, and when we have x goes to 0, when x goes to 0, this y also tends to 0. So this limit can be rewritten as limit, this one is x comma y tends to 0 comma 0 of this x y cube divided by, this one is x square plus y to the power 6, and in place of y cube we have to write mx. So this limit and this, when x approaches to 0, this y approaching to 0. So this limit, this one is x tends to 0, and in place of y cube we have to write mx. So x into this one is mx divided by, this one is x square plus y to the power 6. So this one is m square x square, and finally we get, this one is limit x approaches to 0, m x square divided by, this one is x square plus m square x square. Taking x square common, we get this is equal to limit x approaches to 0, m x square divided by, this one is x square in whole into 1 plus m square, and this x square cancel out, and the limit equal to, this one is m divided by 1 plus m square. So depending upon the various values of m, we get the different type of value. So the limit is not unique, so this limit does not exist. That means option C is correct one, that is limit is does not exist. Question number 65. Here we have to find f of xy, a function is given, and we have to find f of xy at the point 0 comma 0, that is f of xy at 0 comma 0, this quantity is equal to how much. So this can be rewritten as, this one is del by del x of fy of 0 comma 0, and rewriting this as limiting form, we get this one is limit h approaches to 0 fy of, this one is 0 plus h comma 0 minus, this one is fy of 0 comma 0 whole divided by, this is h. But we know that this fy of, h comma 0, this can be written as del by del y of f of h comma 0. Now we have, rewriting this as limiting form, we get this is equal to, or this implies, this one is limit k tends to 0 f of h comma 0 plus k minus f of h comma 0, clear, whole divided by, this one is k, and from this we get this is equal to, this one is limit k tends to 0, this one is f of h comma k minus f of, this one is h comma 0 whole divided by k. Now we have to substitute in the place of x h and in the place of y k, and this become limit k tends to 0 1 by k, this whole into, this can be written as, our function is xy into x square minus y square by x square plus y square. So this becomes, this one is hk into h square minus, this one is k square whole divided by, this one is h square plus this one is k square. Now this k cancel out, and finally when k tends to 0, this gives, this is equal to h cube divided by h square, or this is h. So from this we get the value fy of h comma 0, this is equal to h. Now we have to find what is the value of fy of 0 comma 0. Let put it be the equation 1. Here observe that fy of h comma 0 is found out to be h. Now our aim is to find what is the value of fy of 0 comma 0. So now we have to find fy of 0 comma 0. This can be calculated as, this whole quantity is equal to del by del y of f of 0 comma 0. This is equal to limit k tends to 0 f of 0 comma 0 plus k minus f of, this one is f of 0 comma 0 whole divided by, this quantity is k. Now from this we get limit k tends to 0 1 by k, this into f of 0 comma k minus f of 0 comma 0. Now f of 0 comma k. That means in place of x we have to put 0 and in place of y we have to put k. So our function value become 0. That is the limit this k tends to 0. This one is 1 by k. This 0 minus 0. Because f of 0 comma 0 in place of x comma y we have to put 0 0. Then we get 0 comma 0 minus 0. And finally the result is 0. Now here we get this fy of 0 comma 0. This is equal to 0. Now putting the value of this value and this value in equation 1, we get the result. Here limit h approaching to 0 and fy of h comma 0, this is equal to h. So this one is h minus this one is 0 whole divided by h. So this h cancel out and final answer is 1. That means the correct answer is option number C. So correct answer is 1. Clear? Now come to next question. Here the question asks about if A divides B and this A divides C, then which of the following is true? Here A divides B plus C, this statement is true one. That is option number C. Now you can verify this by using some example. Now come to this one, 67. Here the question asks about if a positive integer n is divided by 5. That means a positive integer, let the positive integer be n. This is divided by 5. Here is the some quotient q and the remainder is 3. Then this n can be rewritten as this one is 5q plus 3. Then our question is which of the number below yield a remainder 0 when it is divided by 5. That means this remainder, if this remainder is equal to 5 or multiple of 5, we get the remainder as 0. So by adding n plus 2 in both the side, we get this is equal to this one is 5q plus this one is 5. So finally this one is 5 is taking common, this one is q plus 1. This one is a multiple of 5. Yes. So our final number is how much? This one is n plus 2. So n plus 2 is the correct answer. That is option number B is correct one. Now come to another question. Here the asymptotes parallel to coordinate axis of the curve. Here the curve is 4x square plus 9y square is equal to x square y square. Parallel to coordinate axis. So first we have to find asymptote parallel to x-axis, so and parallel to y-axis. So we know that a formula asymptote parallel to x-axis can be evaluated by using comparing the coefficient of highest power of x to 0 or equating the coefficient of highest power equal to 0. So here observe that the highest power of x is x square and coefficient are this one is 4 and this one is y square. So from this we get this one is 4, and first of all rewriting this equation as 4x square plus 9y square minus this x square y square is equal to 0. And from this we get this one is 4 minus y square, this quantity is equal to 0, or this can be solved as y square is equal to 4 or y is equal to root over of 4, this is equal to plus minus 2. This gives one asymptote This gives two asymptotes, that is y is equal to 2 and y is equal to minus 2. These are the parallel to x-axis. Similarly, for parallel to y-axis, we have to equate the coefficient of highest power of y is equal to 0. So, here highest power of y is y square. So, finally, the coefficients are, this one is 9 minus x square is equal to 0. And finally, this one is x square is equal to 9, or x is equal to root over of 9. This is equal to plus minus 3. So here we get x is equal to 3, comma, x is equal to minus 3, comma, y is equal to 2, comma, y is equal to minus 2. These are the asymptotes parallel to the coordinate axis. So from option x is equal to 3, x is equal to minus 3, y is equal to 2, y is equal to minus 2. That means option number A is correct one. Now come to another question. So question number 69. Here the function f of x is given as, this one is x minus 1 by x plus 1, and we have to find the Taylor series expansion about the point x is equal to 0. So we know that the function f of x at point x is equal to 0 or x is equal to a, the Taylor series expansion of this function can be written as f of a plus, this one is f dash of a by 1 factorial into x minus a plus f double dash of a by 2 factorial into x minus a whole square plus dot dot dot, this type of thing. So this expansion is known as the Taylor series expansion. So our aim is to find out what is the value of f of a, f dash of a, f double dash of a. So first of all, find what is the value of f dash of a, f dash of x. So f dash of x, that means we have to find the derivative of x minus 1 by x plus 1, that is d by dx of this one is x minus 1 divided by x plus 1. And on solving this, we get the remainder is x plus 1, sorry, the denominator is this whole square, and numerator is x plus 1 into derivative of upper, that is 1 minus upper and derivative of lower, that is 1. So finally, this one is x plus 1 minus x plus 1 divided by, this one is x plus 1 this whole square, and this x cancel out, and the result is 2 by x plus 1 this whole square. Now f, now we have to find what is the value of f dash of 0, because our point is 0. So f dash of 0 is equal to, this one is 2 by 0 plus 1 this whole square is equal to 2. Similarly, now we have to find what is the value of f double dash of x, and f double dash of x, this is equal to how much? So here the derivative of this. So this one is 2 into minus 2 into x plus 1 is to the power minus 2 minus 1 into 1. So finally, this is equal to minus 4 divided by x plus 1 cube. Clear? And the value of f double dash of 0, this is equal to, this one is minus 4 by 1. that is minus 4. So finally, now this f of x at the point x is equal to 0, our Taylor series expansion becomes f of 0. So f of 0 value is how much? First of all, evaluate this. F of 0 is equal to, this one is 0 minus 1 by 0 plus 1. This is equal to minus 1. So minus 1, then plus f dash of 0. And f dash of 0 is value is 2 by 1 factorial into x minus 0, that is x, plus f double dash of 0. F double dash 0 value is, this one is minus 4 divided by 2 factorial into x minus 0 whole square, that is x square. So we have to find the coefficient of x square. So coefficient of x square, no need to write the next term. So here on cancelling 2 factorial and 4, we get the coefficient of x square is equal to, this one is minus 2. So our option number C is correct one. Here option C is correct one. Clear? Now come to another question. Here a function or a mapping f be the mapping from A to B is given, and x comma y be the subset of A. Here let this set be A and this set be B. Here the A set, here is the B set. At the mapping f is, this mapping f is given, and x and y be the subset of A. That means here is the x and here is the y. Here these two sets are distinct or not, there is nothing given, but these are the subsets. Then which of the following is true? So here we know that f of x union y is equal to f of x union f of y. This is true because uh, here the option f of x union y, this can be written as, here is the f of x union f of y. This statement is true one because if we take f as a function, then according to the definition of function, this property must hold. F of x union y is equal to f of x union f of y by using the definition of function. This is the definition of function. Clear? So here option number C is correct one. So thank you for watching my video, and if you like my video, then please like, share and subscribe my video. Once again, thank you.